Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about this problem. So let's get started. Alright, let's see this problem. In this problem we are given an array and we have to find the majority element in a given array. So first thing first, what does it mean by majority element? So an element is said to be a majority element if it appears more than n by 2 times in the given array. And here n is equal to number of elements present in a given array. So let's move ahead and understand this problem with few examples. Let's see this example. Here the input is given as 2, 2, 1, 1, 1, 2, 2. And in this example 2 appears 4 times. And n is equal to 7. And n by 2 is equal to 3. It means 2 appears more than 3 times here. That is why the majority element present in this array is 2 and the index of 2 is 0. So basically we have to return index of the majority element. Okay, let's see the next example. The next example we have 3, 3, 4, 2, 4, 4. Okay, here 3 appears 2 times, 4 appears 3 times. But the value of n is 6 and n divided by 2 is 3. So none of the element appears more than 3 times in this input. So the output of this input is -1. So if the majority element doesn't exist in the array, then we have to simply return -1. So far so clear. Now I hope you have a good understanding of this problem. So let's pause the video and think about an algorithm to solve this problem. Alright, by now I hope you would have at least written basic program to solve this problem. So let's quickly see the brute force approach first to solve this problem. The idea of brute force approach is pretty simple. We have to traverse an array from left to right, and for each element we have to count number of times that element appears in the given array. And if for an element, if we found that the element appears is greater than equal to n by 2, we immediately return the index of that current element. And if we do not found any element, then we simply returns -1. So this is the basic idea of brute force approach. Now let's see the implementation of this basic approach. Here we have a function majority element, and inside of this function we are running a loop from 0 to less than n. Inside of this loop we are initializing count to 0. So the outer loop is going to pick one element at a time, and the inner loop is going to count number of appearance of that element. How? Let me show you. So inner loop runs from 0 to less than n, and inside of this loop we are checking if array of 0 is equal to array of 5. It means the number we have picked on outer loop is equal to the number we are currently traversing. If we found that condition true, then we simply increment the count by 1. And after inner loop we check if count is greater than n by 2 or not. If we found a number that appears more than n by 2 times, we will simply return the index of that element. And if we fail to found any such element, then we simply return -1 in the last. So let's quickly try run this code and see how it works. So here we have array 1, 2, 3, 1, 3, 3, 3, 3. So when we execute this program, the loop begins from 0 till less than n. Okay, so the first iteration the value of I is 0 and the value of count is also 0. So it checks for all the appearance of number 1, and it found that number 1 appears 2 times, but 2 is less than 7 by 2. So we simply ignore it. In next iteration the value of I becomes 1 and the value of count is also 0. We check for all the appearance of number 2. So 2 appears only 1 time, and that is also less than 7 by 2. So we do not have to do anything here. In next iteration the value of I becomes 2. In the element present at index 2 is 3. Now we are going to count all the appearance of element 3. We found that 3 appears 1, 2, 3, 4, 5 times, and the 5 is greater than 7 by 2. So this is the case where we finally found the majority element, and we simply return the index of 3, and that is 2. So 2 gets printed on the screen. So far so clear. Now talking about the time complexity of this function, we are running 2 loops. Outer loop is running n times and inner loop is also running n times. So the overall time complexity of this function comes out to be big of n square. So here you can see that we are not using any extra space except the input array and few variables. So that is why the space complexity came out to be theta of 1. So this approach took big of n square time and theta of 1 constant space to solve this problem. So now let's ask this question to yourself, can we do it better? Can we solve it in big of n time complexity? Do we have any other approach to solve this problem? I recommend to observe the given array once again and think about a solution that can solve this problem in big of n time complexity. Alright, now let's talk about the efficient approach. So what is so amazing about this efficient approach? Well, we are using Moore's voting algorithm in this approach. So how it works? Let me show you. So Moore's voting algorithm works in two phases. In first phase, the Moore's voting algorithm find out the candidate. And this phase guarantees that the candidate is the majority element if there exists a majority element in the given array. And the second phase is just another check over the candidate. It checks whether the candidate found out by the phase 1 is the majority or not. We only need this phase if our array does not contain majority element, because in that case it might be possible that the first phase gives candidate that is not in the majority. So one thing we have to note here that in Moore's voting algorithm, it may not give the index of the first appearance of the candidate or the majority element. It may also give sometimes it may also give middle index of the appearance of the candidate or majority element. So now let's see the implementation of this Moore's algorithm. So here we have a function Moore's voting algorithm, and this function is taking array as input. Okay, we are initializing candidate as 0. The reason is simple. We are assuming that the element present at 0 index is the majority. And then we are initializing a variable count to 1. And then we are running loop from I equal to 1 till less than n. And in each iteration we are checking if the current element we are traversing is equal to the element present at this index. And this index is stored in the candidate variable. Okay. If this condition is true, we are increment the count by 1. If this condition is false, we decrement the count by 1. Okay. And if count becomes 0, we again reset the candidate to I and count to 1. Okay. So from here to here, this is the first phase of Moore's algorithm. And now comes the second phase of Moore's algorithm. It simply checks the count of appearance of the candidate that is found out by the first phase. Okay. So it runs a loop from 0 to n to find out the number of appearance of the candidate. If the count is less than n by 2, it means the candidate that is found by phase 1 is not the majority. So it simply returns -1. Else it returns the value of the candidate variable. So this is all about this function. Now let's quickly dry run this code and see how it works. So we have array like 2, 2, 1, 1, 1, 2, 2. Okay. We initialize the candidate as 0. It means we assume that the 0 is the majority. So we consider this element, that is why we initialize the count by 1. And then we run a loop from next index, that is equal to 1. Okay. So this is the element. We check if this element is same as the previous element or not. Means the element present at index equal to candidate. Okay. And this is same. So we increment the count by 1. So count becomes 2. In next iteration, our I becomes 2. We are at second index. We check if this element is same as index stored in the candidate variable or not, means 0. So 1 is not equal to 2. So we decrement count by 1. In next iteration, the value of I becomes 3. At index 3, we have again 1. We check if this 1 is equal to element present at index, that is equal to count, means 2. It is not equal. So we decrement the count by 1. So as soon as the count becomes 0, so we reach to a number that might be the majority. So we update the candidate to index 3 and reset the count by 1. It means 1 is in the majority now. So moving on to next iteration, in next iteration the value of I becomes 4. Again we got the 1 and we check if 1 is same as the index 3 or not. So we check the 1 is same as the value present at index 3 is not. It is equal, so we again increment the count by 1. In next iteration, value of I becomes 5. At index 5 we have 2. We check 2 is equal to element present at index 3 or not. It is not same, so we decrement count by 1. In next iteration, the value of I becomes 1. At index 6 we have 2. We check 2 is equal to element present at index 3 or not. It is not same, so we again decrement count by 1. It becomes 0. As soon as count becomes 0, we update our candidate to this index. So it means now this index is the majority element and we update the count to 1. So in next iteration our loop gets completed and the majority element, that is 6, gets printed on the screen. And we can see that the value of n is 1, 2, 3, 4, 5, 6, 7, 7. Okay, n by 2 is going to be 3 and 2 appears 4 times, that is greater than 3. So we can see that the 2 is the majority element in this array. So after loop gets completed, the below loop is going to check if the candidate found by the above code is actual in the majority or not. Okay, if it is in majority, it simply do nothing. If it is not a majority, it simply returns -1. So in this case 2 is in the majority, so it's not going to do anything. So far so clear. So this is how the Moore's algorithm works. So do you see what is happening here? Let me show you. So first of all, we consider the first element. So we increment the count of variable by 1, so it becomes 1. Okay. By default, we are initializing count by 1. That is, the reason is simple, that we are considering the first element. Okay. Now we move to next element. Again, we increment count by 1. So it means we have 2 votes for the same person. Okay. Then in next case, we move to 1. So this one is going to cancel out the vote for this person. So that is why we are increment count by 1. Again the next person is 1 and this person is cancelling out the vote for this person. So again we are decrement count by 1. Now count becomes 0. It means we do not have any vote. All the votes are cancelled out each other. So it means the new majority of element is 1 as per the algorithm. Now again we check if next element is 1. Okay, we increment the count by 1. Then we check the next element. Again we have 1, so we increment count by 1. In next element we have got 2. Now this 2 is going to cancel out the vote for this person. Okay, and again this 2 is going to cancel out the vote for this person. So our count becomes 0 and we found that the majority element is 2. It means the index 6. So this is all about Moore's voting algorithm that is used to find the majority element in a given array. Okay, I hope you got it. Now before we end this video, let's have a quick recap of what we have done so far. So in this video we were given a problem, and in this problem we were given an array and our task was to find the majority element in the array. And what is the majority element? An element is said to be a majority element if the element appears more than n by 2 times in the given array. So to solve this problem, we first saw the brute force approach and the time complexity came out to be big of n square. After brute force approach, we saw the efficient approach, and in this approach we have used Moore's voting algorithm and the time complexity came out to be big of n. Okay, so I hope now you have solid understanding of how Moore's voting algorithm works and how to find majority element in a given array using Moore's voting algorithm. So this is it for this video. Thanks for watching. See you in the next video.